Hello everyone. Today I'll be going through the chess robot simulation series, where I focus on how do we implement Moveit C++ API to control the robot and the clipper. So basically, the motivation here is that initially in the previous video we had moved the robot to a desired location, but we had done that using RViz. But we can't use RS to move the robot every single time when we uh, want to get the robot to play chess. So we need to bring about a C++ program which can take in the desired locations and then it can command the robot to move to the desired location. And this can be done using the C++ Moveit interface, which Moveit provides. And that's what I'll be going in, like how, as in how I went about doing this. So in the previous video, the gripper was not been able to control. That was due to the fact that the controller for the gripper was not enabled. So in order to get the gripper to be working with the Moveit interface, uh, uh, we need to create and add this gripper controller. So in order to do that, we can utilize the existing UR5e controller configuration file. We make a copy of that, and then we include this uh, whole set of code to have a controller running for the gripper as well. Once we have that done in the configuration file, we can include that in the launch file so that the gripper controller and the robotic arms controller is called upon during the launch. And also in the ROS controller config file in the Moveit config package, we need to change the namespace of the controllers to what we have defined in this um, particular configuration file. By doing this, we would be able to control the gripper as well with the robot, and this can be done in RViz as well. Next off, we look into how do we write the code for in C++ to get the robot to pick uh, a piece. So in order to do that, we utilize the tutorial given in the Moveit Noetic uh, page, and we have to change certain things for it to work in our case. And I would basically go about just mentioning those areas which I had changed and why I had changed those. So first, we need to have two planning groups. One is for the manipulator and one is for the gripper, so that we could control each of them independently. And next, all other things remains the same. Um, this is to have the move it group interface, and this is to get the joint angle. Once this is done, this is the basic initialization phase. And once this is done, we would be able to write commands to move the robot. In order to move the robot, there are basically few main functions which we use to move the robot. One is set joint value target. This can be used to set the joint values. And here we utilize a predefined joint value, the home position, which we defined in while we are developing the configuration for this particular robot. And then the second most important thing is move dot plan, and here this is the place where it utilizes its own planners to get the planning for the robot from the current position to our desired position. Then, and once that's done, in order to move the robot, we use the group interface dot move. So this will make the robot to go to the desired place using the plan found previously. Now, in order to control the gripper, It's similar in the sense that um, it too has an move group interface. We call that my plan gripper. What changes here is that we don't have any predefined questions. We need to set the joint values. And in order to do that, we utilize the current joint position. We extract the joint angles of the current robot, and then we set the joint angle for what we want to change. And we use the similar uh, steps after that. Set the joint value, plan, and then move. Now, those are for setting the joint angles and moving with planning for desired joint angles. That is forward kinematics. Now, if we want to do inverse kinematics, like having the pose defined and we want the robot to go to that particular pose. So here we need to define the pose, and the pose is defined using position and orientation. And position is defined as X, Y, Z, and the orientation is defined as X, Y, Z, and W, which is uh, in quaternion. And we in order the pose is defined as quaternions and laws, and this is how we define it here as well. So this pose can be extracted by using the TF function um, in Arbis to get the desired position where we want our robot to go. And once we have this position set, like a particular position in the chessboard determined, as in the position and orientation, we can determine all other orientations and position from this because everything is in a grid and we know the size of the grid. So once we get define this target pose, we utilize that to set the pose target. Here instead of set join target, we use set pose target, and then all other things remain the same. We do the dot plan and then we do dot move. Um, and here we just move the robot just on top of the coin. We don't move to the exact location where we want to go. This is because there are chances that there might be some other uh, coins which can come in the place. So what we do is we move it to a particular place just above the desired location, and then from there we just go vertically downwards. Um, this can be done by utilizing the previous target's uh, force, the Z value of the force. What we do is we take that previous one and then we subtract it how much ever we offset it. Um, but and we move that using the same set of sequence. So once all of this is done, um, we have the entire code to um, get the gripper opened, and then we move it to the particular location we want and then close the gripper. So this aspect of writing the code in C++ is done. Now what we need to do is we need to change the CMake list. This has to be done in order to include the packages which we use in the C++ file. And also we need to add the executable. This needs to be done in order for our C++ code to work. Once we have these two files, these two things changed in our CMake list, we would be good to run the entire simulation. And now we would have the entire control of the robot, and we could give it desired positions, desired joint angles, and then the robot will just move there and you could see it. So I can show you the simulation. And this is the simulation of whatever we coded up so far. The robot goes to the position, then goes to the bottom offset, and then it closes the gripper. So this is all happening using the code which we just wrote now. So now we have uh, now that we have the positions for say one particular location here, we could get the locations for any squares from this, and we could ask her to move to any grid which we want. Um, my next step from here is to pick the coin. I have tried to do that, but there was some difficulty in the physics simulation during the class, and that's what I'll be working on in the coming video.